Example number 9, for each of the following functions, because this is a typical question you may have in the homework assignment. So I like to give you, multiple choice question. We want for each one, or here it's not multiple choice. Here, it's a, although there are many options, but we need to work one by one. Yeah. All right. A, B, C, D, E, for each one, each function, we want to get the simplest G function to put the F function. A, B, C, D, E options, I'll give you F function. This function, find the G of A, the simplest, and put this function in the big theta of G. Yeah, so that's the requirement we need to do. Yeah. All right, B, root, so you can see relatively complex, but we need to find a simplest G function to represent the growth function of a complex function. Yeah. C, yeah, so complicated, you see, yeah, very complicated. Yeah. D, yeah, yeah, and E, yeah, last one, okay, last one, yeah. So this is from textbook. So yeah, here I just show you how to do it. Yeah, pretty simple. Yeah, do not get scared. Yeah, pretty simple. Yeah. The first one, we take the dominant term, drop the minor term. Yeah, we know that -1, very little, so we can ignore it. Just take n squared, and then raise to 10th power, you get big theta of n to the 20th. Yeah. The first one, very easy. Yeah. Second one, we also take the dominant term. All right, we ignore the minor terms. All right, then we take the square root, and we can drop the constant 10. We just replace it by constant 1, leading constant. We know that's not important. All right, yeah. Then n squared take root, square root, big theta of n. Our G function very simple. Okay, yeah. So that's the second example. Yeah. All right. E, yeah. E, because it's simple, so I jump to E faster. Floor function, we know the floor function, the difference with the original function, just less than 1. That term too little, so we can ignore that. Okay? That means you can remove that floor function to make it look simpler. Yeah. Yeah. The difference is very small, so we don't worry about that difference. Okay? Yeah. Log base 2, yeah, that base, yeah, here. In computer science, LG, by default, we mean the base is 2. Okay? Yeah. LG. In math, that probably base 10. Yeah. In our computer science, we always mean this log base 2. Yeah. All right. This one, 2 exponential terms. One smaller one, one larger one. When we determine the order of growth, we take the larger exponential term. Yeah, so we don't worry about that. Comparing 2 to the n plus 1 and 3 to the n minus 1, the base 3 term dominates base 2 term quickly, dominates. So we just take the dominant term. All right, so that, because -1, that's little, we can ignore it. Little number, not important, so that we simplify it, big theta of 3 to the nth. Yeah. And the last one, the hardest one, yeah, looks pretty complicated. Yeah. So we need to see which term is dominant. One dominates the other. So we take the dominant one and throw away the other term. Which one you feel when n is very large, that one should be bigger. Can you see it? First one or second one? Larger. When n is very large. Okay? Yeah? Let me tell you the answer. Second one dominates the first one. Why? Why? All right. Look at, so here, product of power function, and a log function. Yeah. Each term is a product of a power function and a log function. Constant, not important. Constant, we know, not important. All right. The power function side, n to the first, that power, n squared. This two can be ignored. So n squared dominates n. All right. How about the log side? Log, that 2, we can bring down as 2 times log n plus 2. Yeah? Because log, we have that property. I don't know if I write it. Yeah. Log parenthesis n plus 1 to the square, we have the property, we put a 2 here, 2 times log function n plus 2. We know this kind of constant not important. So basically we compare the log function and that log function divided by 2 by the log property, just minus 1. We know minus 1 not important, right? Too small. So you have log function here. We ignore constant 2, log function. These two log apart comparable. The log apart basically same order of growth. Same, what I mean, not same value, same order of growth. Okay? Log side, same order of growth. But the power function, the second term, higher than the first term. Yeah. So that's why we take the second dominant term, but we want to simplify as much as we can. So the power function, we use n squared. The log side, we drop the division by 2, log of n. Yeah. So that is the best description of that relatively complex function. Yeah. So with these 9 examples, so I try to cover all the common cases. All the common cases we need to see in this class. Yeah. That should be enough. Yeah. So you just study these 9 examples, pretty much cover all the questions you will see in this class. Yeah. When you see a new question, if you cannot answer quickly, you can go back to look at these 9 examples and see which one can give you some related information for your solution. Okay, all right. Yeah. In our first homework assignment, you will see many questions that we discussed today. Yeah, many questions in today's class. Okay, all right. Yeah. And here I want to mention there is a change of base rule for logarithm. Later we may need to use it because here we use log base 2. Later when we change to a different base, we use this change of base rule like this. Yeah, yeah, here. Yeah. Here I just mentioned it. Later, when we need to use it, I will bring it back. Yeah. Here we may not use it directly. Yeah. Here the reason I talk about this change of base, because in that way you do not need to worry about which base use when we select the g function. Any base pretty much similar. Okay? So you don't worry about the base number because we have this change of base rule here. That's the reason I bring it here. Yeah. But later we have some relatively tricky questions we need to apply this formula. Change our base formula. If you do not know this formula, those questions could be hard. Yeah, could be hard. Yeah, yeah. I will talk about that when we have that question.